In this lecture, we will see the classic traveling salesperson problem using branch and bound technique. We have known that the traveling salesperson problem is a kind of graph algorithm based problem that in which we will be having a starting point. The salesperson has to go to the destination via shortest path by visiting all the vertices in the graph. This is what the traveling salesperson problem. Let we'll see how to solve this traveling salesperson problem using branch and bound method. Branch and bound method we have seen previously that it is just like backtracking only, but here it is used for the minimization problem or optimization problems, that to minimization optimization problems. As part of this, we have seen the knapsack problem, and now we'll see the traveling salesperson's problem. Here we are supposed to minimize the distance between the source and destination via visiting the remaining other vertices in the graph. Here again it is coming under the minimization problem, that is minimizing of the distance between the source and destination. The traveling salesperson problem statement is like this. Let V is equal to G comma E be a directed graph defining an instance of the traveling salesperson problem. Let Cij is equal to cost of edge, that is I comma j, and Cij is equal to infinity if I comma j belongs to epsilon. That means if there is no path between I and j. Let V is equal to n. Draw the state space for the traveling salesperson problem given the cost matrix. Usually the cost matrix is represented by forming the adjacency matrix with a given graph. Assume that this is the adjacency matrix. You may make note of this on paper so that the same adjacency matrix will be used for explanation of this particular example. That means you may also draw a graph with this adjacency matrix. Wherever infinity is there, it means that there is no path available, and the values corresponding the row and column is the distance between the particular vertex to another vertex. So here these are the rows, and these are the rows, and here are the columns. The corresponding distance were arranged in the adjacency matrix form. So this adjacency matrix is considered. In this first step is find the reduced cost matrix. In order to reduce this cost matrix, first of all, we must perform the row operations and column operations. Recall the matrix row operation and column operations that you have studied in your basic mathematics. The same row and column operations will be performed here for identification of the reduced cost matrix. Because with this reduced cost matrix and the cost which is already available, we need to form a lower bound and an upper bound to proceed further in the branch and bound technique. So in order to do that, we are going to use this reduced cost matrix, and we are estimating how much we have reduced out of this particular matrix in every stage, and whether to consider the next vertex or not. And if we consider the next vertex, and what is the cost that we can reduce, and that will be estimated. Thereby we can proceed further to choose whether to go or whether the traveling salesperson has to pass through that vertex or not. So this judgment will be done at every branch. So that is the reason we need to perform, or we need to calculate the reduced cost matrix. In this reduced cost matrix, first we will perform the row operation, that is deducting the minimum element from all the elements in a row. Let we'll consider the first row, in which what is the minimum element that we need to consider. So in the first row, the minimum element is 3. The 3 is the element will be deducted from all elements in the row. So infinity minus 3 is infinity, 7 minus 3 is 4, 3 minus 3 is 0, 12 minus 3 is 9, and 8 minus 3 is 5. So this is the 3 is the minimum value that we have reduced from this row. Like that, from the second row, 3 is the minimum value which is available in the second row, and you take this 3 value and reduce it from this row. And in case of third row, here 5 is the minimum value. This 5 will be deducted from all other elements in the row. Like that, we need to perform the row and column deduction with the minimum value in the corresponding rows and columns. So after performing the row operation, that is deducting the minimum element from the row, this is the resultant matrix. And from the first row we have got 3, second row 3, and so third row 5, fourth row 3, and fifth row 8. So if you sum up this minimum cost in each and every row, each row 3 plus 3 plus 5 plus 3 plus 8, which is resulting into 22. Next, perform the column operation in the same way as we have done in the row operation. Take the minimum element from the column and deduct from remaining elements. So here only one column is having the minimum element other than 0. That is the fifth row, fifth column. So here 5 is the minimum element, and 5 will be deducted from all other elements. Remaining all other columns are having 0 as the minimum element. So only one possible cost that we can reduce from the column is column 5 is 5. So that is the 5 value. Step 2. So we have done with the row operations, that is deducting the minimum cost from the rows and columns, and we have summed up what is the total minimum cost that we have reduced from the matrix, and also the minimum cost that we have reduced from the column. Now we'll proceed to the step 2. If path ij is considered, then that is from this particular matrix, if we want to choose a path that is from I to j, if we want to go, or if the traveling salesperson has to pass through, then if the path ij is considered, then these are the sub points we must remember to proceed further. That is 2.1, in the step 2.1, change all the entries in the row I and column j of the matrix to infinity. That means if you are passing through I and j, that means the traveling salesperson is passing through I to j, then the corresponding value of ij and ji should be placed with infinity. The reason is, if we place infinity, we cannot visit again. That means already that path is visited. To indicate that because of programming, sometimes if we won't place this infinity, there is a danger that we may fall into the infinite loop. So from I to j and j to I, we'll place infinity as a value whenever we attempt to pass from I to j. This prevents the use of any of more edges leaving in the vertex I or entering the vertex j, where A is the reduced cost matrix. As just now I told you, to not to visit again, we'll place it as infinity. Next, step 2.2, set A of j comma 1 to infinity. This prevents the use of j comma 1. So because you have passed through the vertex j, so we should not visit it again, because the starting vertex from which the traveling salesperson will start is 1. So set A of j comma 1 to infinity. This prevents the use of j comma 1. Step 2.3, reduce all rows and columns except for rows and columns containing only infinity, that is, at least one value of each row and each column should be 0. Step 2.4, if R is the total amount of subtracting, then step 3 in the step 2.3, then the cost that is reduced is cost of S is equal to cost of R plus A of I comma j plus R. So in the above problem, the cost what we have reduced is 3 plus 3 plus 5 plus 3 plus 8 plus 5. That is the minimum cost along with the rows and minimum cost along with the columns. If you sum up, 22 is the minimum cost that we have reduced via rows operation, and the 5 is the cost that we have reduced via column operation. So 22 plus 5, which is equal to 27. So L is equal to 27, and that is the lower bound, that the minimum cost that we have reduced via row and column operation is 27. And let me consider U as the infinity, because infinity is the maximum cost that is available in the rows and columns. So upper bound is infinity. Node 1 is the starting node, as the number of nodes is 5. Node 1 can traverse only one of the node. That is, from node 1 we can pass through either 2, 3, 4 and 5. So recall the knapsack problem that we have seen in the last lecture regarding the branch and bound. So from 1 we have the chance of going to 2, 3, 4, 5. We'll do the operation that we have studied in the step 2.1. If we pass through 1 to 2, okay, if we pass through from 1 to 2, 1 to 2 should be replaced as infinity and 2 to 1 as also infinity. Then perform the row and column operations by reducing the minimum cost. Then you look at the calculate the lower bound using this particular cost formula. Then we can also pass through 1 to 3, and same traveling salesperson can also pass through 1 to 4 and 1 to 5. So check all the possible operations, possible chances to visit other vertices from 1. So here consider 1 to 2, that is the salesperson wants to go from 1 to 2. Then we are supposed to place this cost matrix of 1 2 and 2 1 to be set as infinity. So 1 2 and 2 1 should be placed as infinity, along with the first row and second column must be placed with infinity. So this is first row and second column is placed with infinity. Now 2 comma 1 to infinity. So 2 comma 1 should also be placed as infinity, because 1 comma 2 we have placed as infinity and 2 comma 1 should also be placed as infinity. According to step 2.2, the corresponding row and column values should also be placed as infinity. So this is in first, that is first row should be placed as infinity and second column should also be placed as infinity. Now with this setup, that is, if a salesperson wants to go from 1 to 2, then cost of 1 to 2 is infinity, cost of 2 to 1 to be placed as infinity, and the first row to be placed as infinity, second column should be placed as infinity. Now this is the cost matrix we are having. Now perform the row and column operation as we have done in the previous step. That is, identify the minimum element from the row and deduct it from the remaining other elements in the row. In the same way, after performing the row operation, identify the minimum element from the column and deduct it from the remaining elements from the column. So this is the matrix after choosing this 1 to 2 path. Then reduce the row. So in this first row, all are infinity, so no need to do any operation. In the second row, 1 is the minimum element or minimum cost that we have find. So take this minimum cost and reduce from remaining other costs. So it will be 2, 10 and 0. Now like that, in the third row, 0 is the minimum cost, reduce it from remaining elements. And in the fourth row, 2 is the minimum cost, reduce from other elements. So whenever you do this, so 1 is the minimum cost that we have reduced and 2 is the minimum cost that we have reduced. So 1 plus 2 is equal to 3. From this, identify the minimum element from the in the column, each column, and reduce it. So from the first column, we didn't find any minimum element. Anyhow, here 0 is the minimum cost we find. So 0 minus anything is 0. Anything is that value only. So like that, if you look at, we didn't find any significant cost to reduce or to minimum cost to reduce from the remaining elements in the column. So according to formula, so we have done the first three steps. Then the last step, the cost to be calculated. So the cost of the row plus A of ij that we have made as infinity plus R. So previously we have got the cost as 27. 27 plus A of ij. Get the A of ij value from the matrix that we have obtained in the previous step. That is the reduced matrix that what we have got. The reduced matrix is like this. Here A of ij, that is A of 1 comma 2 is 4. So 4 to be considered here. So previous cost, that is 27, and plus 4, A of ij is 4, and the cost that we have reduced in this step, that is 3. So 27 plus 4 plus 3, which is equal to 34. This is the cost that we have reduced. That is the reduced cost that what we got when you traverse from the vertex 1 to vertex 2. Now, if we traverse from 1 to 3, so whenever we traverse from 1 to 3, that is the second branch here. From 1 to 2 is over. Now 1 to 3 to be considered. So whenever 1 to 3 is considered, the A of 1 3 will be infinity. A of 3 1 should also be infinity. The first row should be infinity. Third column must be infinity. Same thing will follow here. So the first row is infinity. Third column is infinity. A of 1 3 is infinity, and A of 3 1 is infinity. So this thing we have made. Now on this matrix, identify minimum element from the each row and reduce it from the remaining other elements in that row. So in the first row, anyhow, infinity elements are there, so we cannot reduce anything. In the second row, 0 is the minimum cost that we identified, so we cannot, even though we reduce 0 from any other element, the same element will remain. In the third row, the minimum element is 1, so reduce 1 from remaining other elements. So 2, 0 and 7. So 1 is the cost that we reduced so far. Next, I go for the fourth row. So here 0 is the minimum cost that we have find. So and the fifth row 0 is the minimum cost. So no need to do anything. Now observe the minimum cost on the column. So on the first column there is no minimum cost, and in second column also no minimum cost to be reduced, because 0, if 0 is there, we can ignore that column. So infinity here in the third column, 0. In the fourth column we find 1. So 1 can be reduced. So 1 is reduced from remaining other elements in that column. A of 1 comma 3 value. So what is the A of 1 comma 3 value that we have obtained in the previous step? That is after making the reduction in the original matrix, we got the matrix that what we have obtained is, so in this 1 comma 3 is 0. So the cost to be reduced when traversing from 1 to 3 is 27 plus 0 plus the cost reduced in this visiting from 1 to 3 is 2. So 27 plus 0 plus 2 is 29. Now one branch is over. Now we'll move to the another branch. So 1 to 2, the cost what we have got is 34. If we traverse from 1 to 3, the cost what we got is 29. Now we'll go for 1 to 4, that is another branch. Next 1 to 5. The same way how we calculated 1 to 2, 1 to 3, we'll calculate 1 to 4 and 1 to 5 also. Now consider the traversing from 1 to 4. So the first row should be infinity, fourth column should be infinity, cost of 1 comma 4 should be infinity, cost of 4 comma 1 should be infinity. So once you do this, identify the minimum element from the row and reduce it from the remaining elements in the same row. And after doing the row operation, perform the column operation. Then in this step, we'll get the cost reduced as 2, and the previous cost that is obtained in the previous step is 27, and a of 1 comma 4 is 9 from the reduced matrix in the step 1, and the cost reduced by visiting from 1 to 4 is 2. So totally we got 38. Now consider 1 to 5. The first row should be infinity, the fifth column should be infinity, and a of 1 comma 5 should be infinity, a of 5 comma 1 must be infinity. So identify the first minimum element from each row and reduce the minimum element from remaining other elements in the same row. Do the same thing after from via columns after performing the row operation. So once you do this in this 1 comma 5, so 1 comma 5 is 0, the previous cost is 27, and the cost that is reduced in this visiting 1 to 5 is 1. So where we got the total as 28. So here node 5 has the least cost. So whenever we traverse from the 1 to 2, the least cost is 20, lower bound is 34, and if you traverse from 1 to 3, the lower bound is 29. If you traverse from 1 to 4, lower bound is 38, and here 1 to 5, the lower bound is 28. So among the traversing from 1 to 2, 1 to 3, 1 to 4, 1 to 5, the lower bound what we have achieved is 28, which is the lower bound. So that will go in the direction of 1 to 5, and we will try to explore the alternative from 5. So anyhow 1 and 5 is visited. So only thing is from 5 either you are supposed to visit to the 2, 3 and 4. So 1 to 5, consider 1 to 5 comma 2. So consider 1 to 5 and try to visit the 2, next 3 and 4. So whenever we visit 1 to 5 and 2, so the first row is infinity, the second column must be infinity, and fifth column must be infinity. Then 2 to 1 should be infinity. So 2 to 1 should be infinity. And after doing this, the reduce, identify the minimum element from the row and reduce the minimum element from the remaining elements in the row. After doing the row operation, perform the column operation and sum up what are the costs that we have reduced. So the previous cost that we have identified is 28. That is traversing from 1 to 5. The lower cost, that the lower bound that we got is 28. 28 plus traveling from the 5 to 2 is 6. So 28 plus 6 plus the cost that we have reduced in this step is 2. So totally 28 plus 6 plus 2 is 36. Now same thing we'll consider the 1 to 5 and 3. So whenever you say 1 to 5, 3, the first row is infinity, third column is infinity, and fifth column is infinity. Identify the minimum element from the row, each row, and deduct it from the remaining other elements on the same row. In the same way, column also. So 3 comma 1 to be infinity. So whenever you do this, the cost to be reduced is 1. Totally 1 is the cost reduced here. And what is the cost from 5 to 3 in the matrix that we have obtained at by visiting 1 to 5 is 0 here. Cost of 5 comma 3 is 0. So previous step value is 28 plus 28 plus 0 plus the cost reduced in the step is 1, that is 29. Now consider the path from 1 to 5, from 5 to 4. So first row should be infinity, fifth column must be infinity, and fourth column must be infinity. Reduce from the row and column, we will get the cost as 28 plus 0 is equal to 28. So whenever we traverse from 1 to 5 and 5 to 2, 5 to 3, 5 to 4, the lower bound that we obtained via visiting from 5 to 2, 5 to 3, 5 to 4 are 36, 29 and 28 respectively. Among these three lower bounds, 28 is the lowest value. So we need to traverse in the direction of 1 to 5 and 5 to 4. From 4, there are two alternatives to visit, that is 4 to 2 or 4 to 3. So same thing we'll do here, 1, 5, 4, comma 2. So first visit 2. So whenever you say consider 1, 5, 4, so first row should be infinity, fifth column should be infinity, fourth column should be infinity, and second column should be infinity. Then on this matrix, identify what is the minimum value in each row and subtract the minimum element from the every element in the same row. So once you do this, the performing the row operation, then followed by column operation, the minimum cost that we have reduced is 3. So the previous value, that is the cost that we have considered from 5 is 28. So previous cost is 28 plus it is 4 to 2. The cost of 4 to 2 in the matrix that what we have obtained previously. So in the previous matrix, that is by visiting from 1 to 5 and 5 to 4, the resultant matrix will be having 4 to 2 as 0. The same 0 will be considered. So 28 plus 0 plus the cost that is reduced in the current step is 3. 28 plus 0 plus 3 is equal to 31. Now consider 1 to 5, 5 to 4, and already 4 to 2 is over. Next branch that is possible is 4 to 3. So first row is infinity, fifth column must be infinity, fourth column must be infinity, third column must be infinity. Perform the same row operation and column operation by taking the minimum cost. So the value that we have reduced here is 3 plus 6, 9, and 28 is the previous cost. Now the cost of 4 to 3 in the previous matrix that what we obtained. So 4 to 3 cost is 1. So 28 plus 1 plus the cost reduced in the current step is 9. So 28 plus 1 plus 9 is 38. Now in this branch, from visiting from 4 to 2, the lower bound is 31. Visiting from 1 to 4 to 3, lower bound is 38. Among these two, the lower bound is 31. So lower bound is 31. So you try to expand this. So from already 1 is visited, 5 is visited, 4 is visited. Only vertex that is left over is 3. So try to visit 3, 1, 5, 4, 2, 3. So first row should be infinity. Then fifth column, fourth column, second column, third column should be infinity. So 3 to 1 should be infinity and 1 to 3 should be infinity. So whenever you make this, previous cost is 31 plus 0 is 31. The traversing path should be like this. The salesperson has to start from 1. He has to visit 5, then 4, then 2, then 3, then 1. So this is the round trip that will be done by the traveling salesperson with the cost as 31. So this is the way how we'll solve this traveling salesperson problem using branch and bound technique.